revise with you the end of term two final exams revision for Pure Mathematics 1. You can see here, I am sharing the screen with you. And this revision pack is actually related to the extended version, which was shared with some of the students. So I will try to solve all the questions which are provided from the book and from the past paper. So that's why it is called extended version. And there is a concise version in which we just put the past paper questions for the students to revise for the exam. Okay, you can see the study list. In the study list, in this video, video number 1, I'm going to talk about circular measures. So I have 3 units to cover. Conversion of radians to degrees, degrees to radians. And then second one is how to find the arc length and sector area when we are measuring in radians. And the third thing is some problems in which we will use trigonometry formulas, sine rule, cosine rule, area of a triangle to deal with those type of situations when the angle is given in radians. So in the book, you can see page number 75 to 85 if you want to study from the book. So the book is this, Complete Pure Mathematics 1, Cambridge International AS level. So you can also practice from my iMaths, my lesson presentations provided on Teams and OneNote, all the homeworks and quizzes there, they can also be studied for this reference. So let's start. Mm. Yes, the most important thing before I start, MF19 formula. So guys, those students who cannot memorize the arc length formula, so in the final exam, at the end of the paper, there is a list attached of this MF19 where you can find under mensuration, arc length is r theta, theta is in radian, and the area of a sector is half r squared theta. So no need to find it. You will be knowing in advance that arc length of a circle and area of a sector is provided here. So circular measures, guys, you can see he has given you the angle in degrees, and I want to convert it into radians. So what you need to do, guys, 15 degrees. If anyone wants to convert any angle from degrees to radian, you need to multiply with pi and divide it by 180. So the reason is, if anyone wants to move from degrees to radians, you need to multiply pi and divide it by 180. And if you want to move from radian to degrees, you have to multiply with 180 and divide it by pi. That's the thing you have to do. So this is the first part. The second part is 225. You need to times with pi and divide it by 180. And the third one, same thing, 135 times with pi divided by 180. As the examiner said, you have to put the answers in terms of pi. So don't touch this pi, keep it as it is, and try to simplify them with the help of calculator. So you have calculator, just write fraction 15 over 180, it gives you 1 over 12. So my answer is 1 over 12 along with pi. Some students, they want to write in another form, that can be pi over 12. So both are fine with us. Second one is 225 divided by 180. It gives us 5 over 4. So I can write 5 over 4 pi or 5 pi by 4. The last one, 135 divided by 180. It gives you 3 pi by 4 or 3 over 4 pi. Next. Now we have radian measures and we need to convert them into degrees. Remember how we do this? Pi over 10. We need to multiply with 180 and divide it by pi. Because I want to move from radian to degrees. For this reason, 180 in the numerator and pi in the denominator, you need to multiply. The B part is 7 pi over 180. Again, you want to convert it into degrees. 180 is on the top and pi is down. And then you simplify. C part, 3 pi over 8 times with 180 divided by pi. The important thing here, which you need to take notice of this, that pi's are easily cancelled. Now I'm going to use my calculator. So see it on the screen. I'm going to write it here, 180 over 10, which gives me 18. So what I was doing, I was trying to convert radian into degrees. So my answer is 18. Don't forget to put a small circle because I want to get my answer into degrees. Next, 7 times 180 over 180, and it gives us 7 degrees. Then next one, 3 times 180 and divided by 8, it gives us 67 point degrees. Now we come to the question number 3. First, you need to understand that this portion, a part of a circle, I call it as a pizza pastry. So this is called a sector. In mathematics, it is called a sector, right? Yani in this diagram, you can see he has written here A. A means he's asking you what is the area of a sector. So this pizza pastry has a small size. So mathematicians, they call it as a minor sector. And this Pac-Man looks like it is called a major sector. So I can say minor sector area plus major sectors area is equal to the total area of a circle. I hope you understand it. Okay, I'm actually interested into this area, and this sector. Examiner will be asking you what is the area of a sector, and he will also be interested into only the arc length. And this arc length is a small part of a circumference. That's why mathematicians, they call it as a minor arc. And the other part is major arc. And boys, if I want to add the length of minor arc and the major arc, if you add them up, what is this? Come on, it is equals to circumference of a circle. Okay, this is just for your knowledge. As I said in the final exam, at the end of the paper, you guys will be provided with MF19, where under the mensuration section, area of a sector and a minor and the arc length formulas are provided. Let me write it again. Area of a sector, half r square theta. Theta is in radians. In IGCSE, you took from me area of a sector, but I'm not interested right now here. We are not going to use that. But that one was theta over 360 times pi r square was the area of a sector. Why? Because over there I was measuring angle in degrees, and right now I'm measuring angles in radians. So in the exam, it's up to you to put theta rad or don't write it. By convention, teacher knows that this angle is in radians. Okay. If the angle is in degrees, then you have to mention on the top of that angle small circle which shows that you are measuring angle in degrees. Hina, no problem. No need. Okay. What is the arc length? S is equals to r theta. So these two formulas you need to memorize. Okay. Let's do the questions which are given over here quickly. Now, he gave you theta as 6 and S is the arc length is 10 centimeters. A part, S is equals to R theta, S is 10, radius is 6. I want to get theta, so 10 over 6 will be your theta, and then you can simplify it. Go to the B part. He said area is 1000 millimeters squared and radius is 25 millimeters. Why is now he's talking about area of a sector? What is the formula for area of a sector? Half r squared theta. Substitute 1000 half radius 25 squared times theta. Now send the things to the other side. No worries, you can easily simplify later on. Now let's go to the C part. He gave you theta, he gave you S, and now I want to find radius. So S is equals to r theta. S is 20. Radius I want to find. Theta is 0.8. So 20 over 0.8 will give you the radius. Last part. He said area is equal to 50. So I'm going to write half r squared theta. 50 half radius I want to find. Theta is 3 pi by 4. Use your algebra skills. Send the things to the other side. 2 is gone there, 4 is gone there, and 3 pi is gone to the denominator of the left-hand side, r square. I'm going to put a square root here, and that will give me the radius. Let's go to the question number 4. Interesting question. It looks like the guy has made hexagon, a regular hexagon inside it. It looks like an IGCSE question. So I want to find the shaded regions. What I'm going to do, I remember in IGCSE, I have taught you these type of questions. Can I just make 6 equilateral triangles? Do you agree with me? There are 6 equilateral triangles. Why? Because this angle, the total is 360, and 360 is divided into 6 equal parts. When I do this, I'm going to get 60 degrees in each triangle. Does it make sense? Yes, it is. Wow. You remember that this is the radius and this is the radius. So it looks like an isosceles triangle because the two sides are equal. So if this is 60, this is x, this is x. Oh, wow, this is 60, this is 60. In which triangle all angles are same? You'll say, Mr. Omar, it happens in equilateral triangle. Wow. So this, I'm gonna get 6 equilateral triangles. Did he provide us the radius of this? Yep. So the radius is 10 centimeters. I'm gonna say that this is 10, this is 10. Let me erase everything now because I have explained. I'm gonna focus only on one equilateral triangle. This is 60 degrees and the radius is 10. Now use your knowledge of IGCSE, where Mr. Omar has taught you the trigonometry formula for the area of a triangle. Area of a triangle was what? The two sides are given and included angle is given. So you are going to use half 10 times sine of 60 degree. Oh man, please be careful. I'm going to work in degrees. So your calculator must be converted into degree mod. You have to confirm in the exam throughout, because sometimes in trigonometry you are working in degrees and some of the times you are guys are working into radian. So be careful that which mod you have selected to do some calculation. So here I'm using degrees. So I'll try to find this answer. Second thing is I will try to find the area of a sector. What is the formula for the area of a sector? Half r square theta, which is 60 degrees. I'm not gonna 60 degrees guy, take 60 degrees because you remember 60 degree can be converted into radians. How? Times with pi over 180 will give me pi over 3. So rather than writing 60 degrees, I'm gonna use pi over 3. So here half r squared theta which is pi over 3. And why not? I can use also here pi over 3. Now, my calculator is in a radian mode. This is triangle. This is sector. Can I find this shaded segment in mathematics? The area which is included between a chord and an arc is called a minor segment. So let us take out our calculators and everything you need to insert into your calculator. So let's check it out. What the answer comes to us? Half 10 squared times pi over 3 minus half times 10 times 10 times sine of. I will write here, because my calculator is in a degree mod, it's better to convert it into radians. So now pi over 3. So I got my answer 9.06. That is the area of one segment, but I have 6 segments, so I need to multiply this answer with 6. Times with 6, it gives me 54.3. So 54.3 is the total area of 6 segments. 54 centimeters squared is the area of this, 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 this. Did you see? I found that one area and then I multiplied with 6 to get the required area. Next question. He said that the arc length is 15 pi over 4. Which one is 15 pi over 4? This is 15 pi over 4. Find the exact angle ABC. This angle is to be found. This angle theta. Okay, arc length is given. S is equals to r theta. S is 15 pi over 4. Radius is 5, and I want to get theta. Send the 5 to the other side. 15 pi over 5 times 4. Yeah, so theta will comes to you 3 pi over 4. One part is done. Second thing is find the exact area. Guys, if examiner uses this word exact, it means don't try to write your answer in decimals. You need to keep the same answer, maybe in the surd form or radical form or pi form. So check that what the final answer comes to you. Find the exact area of a sector. This is A part, and I'm going to get the B part. Area is equals to half r squared theta. Area, radius is 5 squared theta. I have just found 3 pi by 4. Again, I request you, don't touch the pi. Don't try to write 3.142 since the examiner is required your answer in an exact form. So simplify. I'm getting my answer 75 over 8 pi, and which unit he has used? Meter. So I'm going to write meter squared. That's all with it. Now, last question from the book. The guy said, find the arc length BD. Oh, did he provide us any information? The radius is known to me. And what else I have? What else I have? He gave us twice AB. AB is given. AC is given. And BAC angle is also given. BAC. Wow. So the central angle is provided by the examiner, 0.5 rad. And it's in radians. Done. Am I ready? So how can I find the arc length BD? S is equals to r theta. S is equals to r theta. Radius is 10 and theta is 0.5. So my answer is 5 centimeters is the arc length. Next part is find the perimeter of the shaded region. So perimeters, you need to understand arc plus DC plus CB. So there are three, things or sides and curves you need to add to get your final answer. So I'm gonna find the perimeter, which is BD arc, EC, and CB. Straight line. BD arc we found 5. CD, you remember guys? This is also a radius, which is 10. Total is 13, so that should be 3. So DC is 3. CB, oh, CB. Remember cosine rule from IGCSE? In IGCSE, we took it that if the two sides are given and their included angle is given, we can find the opposite side. So the opposite is always equals to a big square root, side square plus side square minus 2 times side times side times cosine. Now you understand what Mr. Romer is about to speak. I will say, check your calculator. It should be in radian mod because my angle is in radians. So I'm going to write everything. Square root 10 squared plus 13 squared minus 2 times 10 times 13 times cosine 0.5. And I got my answer 6.389 or 6.390. 6.390. So I'm going to write here 6.390. Add them up. 5 plus 3 plus 6.390. So it gives us answer 14.39 or 14.4 to the three significant figures. Centimeters. Let's go to the C part now. C part, find the shaded area. So I need to find the area of the big triangle ABC. So shaded area, it is equals to the area of triangle, which ABC minus sector. Which sector? ABD. Triangle, I use the trigonometric formula half times side times sine of the angle between them, and sector area half r squared theta, half radius is 10 squared and theta is 0.5. Again, check your calculator. Is it in radian mod? Yes. So write everything in a calculator. Half times 10 times 13 times sine of 0.5, close the bracket, minus half times 10 squared times 0.5, and I got my answer 6.16. Don't forget to write the units, centimeter squared, and this answer is in three significant figure as per the rules of Cambridge. Wow. Here we are done with the book questions which I put on the revision pack. Now we started with past paper questions. The beauty of the revision pack which I have set for you, I tried to select the best questions which can give you the overall idea how examiner normally give the questions from on circular measures. So this question is in front of you. The first thing of doing past papers is read the statement one time or two times and underline those points which are critical and new words for you, or maybe they will be used later on. The diagram shows a sector ABC. This is a sector. Done. If he gives you a sector, he must tell us about the radius. Yes, the radius is R, and this is also R. The line perpendicular from BD the line is perpendicular to AC. Okay, so this is perpendicular, this is 90 degree. We understand. Angle CAB is in, okay. Now he said theta is pi over 6, yani 30 degrees. Find the exact area of BCD, this shape, BCD. I'm going to shade it for you so that you can see what type of area is required by the examiner. How much marks he has put for it? 3 marks. I'm going to ask you like an examiner, think how he has put 3 marks for it. For sure, you will say, Mr. Omar, first of all, we need to find the area of this sector. Okay, good. Try to find the area of a sector. Another thing which you have noticed, examiner has not given you numerical value of the radius. That's why the examiner has asked you, write your answer in terms of R. If he had provided you the radius numerical value, he could have asked you, find the value of, find the exact area. Okay, so let's do area of a sector, which is half R square theta. This is the sector area, ABC sector. Done. Now, what about the right angle triangle ABD? Area, triangle ABD. The right angle triangle, and go back to mechanics. Mr. Omar has taught you how to find the perpendicular, yani opposite, and adjacent if I give you R and theta. You will say, Mr. Omar, this is always R sine theta and this is R cosine theta, because in front of the theta, you call it R sine theta and R cosine theta. May I use this result over here? So that BD should be R sine theta and that AD should be R cosine theta. I hope it clears to you guys. Now I want to find the area of a triangle. I'll use half time base times height. Base is how much? R cosine of theta, and height is R sine of theta. My formula is half R squared, because R times R is R squared sine theta and cosine theta. So this is the area of a triangle and this is the area of a sector. Examiner wants this green portion, so I need to subtract, but you should use theta pi by 6. I'm going to write now area BCD sector half radius squared. Theta is pi over 6. So this is the sector area minus half radius squared sine of pi by 6 cosine of pi by 6. Okay, guys, can I combine any half, and this is 6 and this is pi? I'm going to write it like this: 1 over 12 pi r squared. Now I need to know what is sine pi by 6 and what is cosine pi by 6. From the calculator, you make sure your calculator is in a radian mode. Pi over 6 times cosine fraction pi over 6. Close the bracket and see what is the answer. Square root of 3 over 4. And if you multiply with 1 over 2, it gives you what? Square root of 3 over 8. Square root of 3 over 8 r squared. So did you see my answer is in r squared terms? If you want to factorize it, you can take r squared common and write 12 pi over, sorry, pi over 12 square root of 3 over 8. Maybe you will be thinking, why, Mr. Omar, you are not writing the answer in decimals? Didn't you see the examiner has mentioned over here exact area? Exact means keep your answer in pi form, insert form like a square root of 3. So this is my final answer. Next part, B part is, he said, given instead the length of BD is square root of 3 over 2 R. You remember the BD length was how much? The BD length was R sine theta. So let me write here R sine theta is equals to R sine theta. It is equals to, he said, put it equals to square root of 3 over 2 R. Can I cancel R with the R? And now I use theta is equals to shift sine square root of 3 over 2. It will give me 60 degrees from the calculator if my calculator is in degree mode, but I would prefer the calculator must be in radian mode. So shift sine of square root of 3 over 2 will give you pi over 3. Now my angle is pi over 3. I want to find up exact perimeter of BCD. Perimeter means I need this, this, and this. This is a perimeter. If you want to find perimeter, you need to know BD straight line, CD straight line, and the arc is BC. Arc is BC. BD length is already given by him, which is equals to square root of 3 over 2R. CD length is this length. So you have radius R, subtract R, cosine of theta came to us how much? Pi by 3, which is 60 degrees. When you check it on the calculator, it will give you minus R over 2, and the answer is R over 2. Clear? The total length for this one is R over 2 for you. How did I do this? I subtracted AD from AC. So it came to me R over 2. Now BC is R theta, radius is R, and theta is found by me equals to pi over 3. You may take R common if you want it. Square root of 3 over 2 plus half plus pi over 3. Since he says you need to give your answer in a exact form, no need to further simplify it. That's all with it. We go to the question number 2 now. I want to find angle BOC. So BOC, this angle is required. Total angle of the sector, central angle, BOC requires. Now, examiner gives you this arc length. This exam. So if he gives you this arc length and he gives you this radius, so why not? I can concentrate on this sector to find this angle. So let's try to apply S is equals to R theta. S is 2, R is 10, and theta I want to find. So theta is equals to 2 over 10, which is 0.2. So this is 0.2. Can we add them together? So 0.2 plus pi by 6. We will add them together and it gives us the total angle BOC. So 0.2 plus pi over 6. In decimals, we get 0.724. 0.72. Okay, so we found the angle BOC. Now, he uses a command word hence. Hence means whenever the examiner uses this word hence, it means the previous part, whatever you have got, you have to use it. Sometimes examiner uses a word hence or otherwise. Hence or otherwise means you may use the previous result, or it is up to you. If you have any other technique, you can use that. But hence tells you, restricts you to use the previous result. So this is three significant figures. Make sure your answer has to be three significant figures. On the front page of the exam, it is written categorically by the examiner, your answer has to be three significant figures if it is a measurement. I'm talking about radian measure. Maybe the students will be thinking it has to be one decimal place. No, 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 no. So area of BPC. Now I want to find the area of this BPC area. So everyone will agree with me, the sector minus triangle. Sector, so shaded area. Sector, BOC, minus triangle, BOP. Now sector is half, the radius is 10, and theta we have found it 0.724. You may write one more decimal place if you want it. Triangle is half. Oh yes, now I have to know this vertical height, which should be what, 10 sine of 0.724. And what is this, guys? 10 cosine of 0.724. So half time base times height, half time base. And height is that will give you the area of a sector. So write everything in a calculator. Half times 10 squared times 0.724 minus half times 10 times cosine. Is your calculator in radian mod? Yes. 0.724 times 10 times sine of 0.724. I wrote everything on my calculator display. Here you go. I'm going to get my answer 11.4. That's my 7.4 centimeters squared. Three significant figures. Now we go to the question number 3 on circular measures. I want to find the perimeter of the shaded region. It has 5 marks. Which thing is not given? You will definitely say, Mr. Omar, radius is not given. Yes, this looks like an isosceles triangle because the two sides are same. Wow, I want to find the opposite side to 1.8, which serves here as a radius of a sector. Shall we use our IGCSE knowledge? The answer is yes. Mr. Omar, I have the two sides. I have the included angle. So the radius will be found by using the cosine rule, which is 6 squared minus 2 times 6 times 6 times cosine of the angle 1.8. Go to the calculator and try to write it 4 significant figures. Cosine of 1.8, and here you get the answer. It came to me 9.3, 9.40, 9.40. So the radius is 9.40. I want to find perimeter. So perimeter is made up of 3 segments like this, 2 straights and 1 curve. What it should be? Its DC will be S is equals to R theta 9.4 Oh man, I don't know this angle, but it's not a big deal. It says isosceles triangle. This is X, this is X. I can easily find it. The sum of the three angles in a triangle is 180, but in degrees, pi. Pi minus 1.8 divided by 2. Let's try to calculate from the calculator. Pi minus 1.8 divided by 2, it gives you 0.671. 0.671 to the three significant figures. Wow. I'm ready to find the perimeter, which is r theta. So theta, I found 0.671. So this is my arc length. Radius 9.4. So I'm just interested here. So it should be 9.4 minus 6, which will be 3.4. Clear? And this is already given to me 6. So perimeter will be 6 plus 3.4 plus 9.4 times 0.671, and then you get your final answer. 6 plus 3.4 plus 9.4 times 0.671, and I got my answer 15.7. Interesting thing is this, it has 5 marks. And you have lots of calculations included. Cosine rule is included. You use S is equal to R theta formula. And then you try to find the length of all the three sides given. That's why he has given here 5 marks. Area of a shaded region. So obviously sector minus triangle. So shaded area is equals to sector. Which sector? ABC. Sector minus triangle. ABC triangle. So sector is half 9.4 squared, half r squared theta, which is 6.71. Triangle is, I'm using the trigonometry formula, half times 6 times 6 times sine of the angle between the two arms, and then we get our answers. So let's go ahead. Half times 9.4 squared times 6.71 minus half times 6 times 6 times sine of 1.8, and then you get your answer 278, I mean 279 centimeters squared. Three significant figures. Now we come to the question number 4. In question number 4, we want to find the perimeter of the shaded region in terms of R. This one, this plus this, right? For this, I'm gonna do what? I'm gonna look at this question. This is how much, if I just try to divide it, and this is how much this looks to me. I don't know what this angle is. Suppose if this is theta, so that should be r sine of theta, and that should be r cosine of theta, and the same thing is this is r cosine of theta. Clear? Now, examiner says the distance PQ is 5/3r. So for me, it looks like r cosine of theta. Guys, let me explain you again how I wrote r cosine theta. Actually, for me here, this is a right angle triangle. Agreed? It's a right angle triangle. And also, if I draw this dotted line joining A with Q, I get another right angle triangle. This is also R. Now, if I say this is theta, theta in radians, okay? So as per the rule of right angle triangle trigonometric ratios, this should be r sine of theta. Agreed, guys? I'm talking about this side. Now this side will be what? R cosine of theta, and this is also r cosine of theta. So can I say if I add r cosine theta, that should be equals to total PQ side? Answer is yes. So write it here, r cosine theta plus r cosine theta, that should be 5 over 3r. So this r cosine theta is 2r. Cosine theta is equals to 5 over 3r. Can I send the things to the other side? 5r over 6r, because 2 multiplied with 3 6, and r also. So can I cancel r with the r? Wow, it helps us to get the value of theta, guys. So theta is equal to shift cosine. Your calculator must be in a radian mode. 5 over 6. 0.586, 0.586. So we found the angle theta with us. Now we want to find our perimeter. Will you allow me to do one very important thing? If I don't want to calculate this theta, yani I got this answer, but why not? Since everything is becoming exact to me, so my cosine theta is 5 over 6. Guys, is it possible for cosine theta is 5 over 6? So what should be my sine theta? Remember, SOHCAHTOA, you have adjacent, you have hypotenuse. Can I find opposite? So opposite will be equals to hypotenuse squared minus adjacent squared. So 6 squared is 36 and 5 squared is 25. And can I say this is square root of 11, guys? Is it? So my opposite is square root of 11 over hypotenuse is what? Which is 6. I'm just writing it here. Maybe I will use this thing because the examiner is interested in writing the answer in terms of R. Yeah. So I want to find a perimeter. So why not I find only this? And then I multiply this blue arc with 4 because I find 4 congruent arc lengths like this. So I will just try to find this one. How much it is? It is r theta, and the theta I have found it as shift cosine of 5 over 6. Okay, shift cosine 5 over 6, or I can write cosine of 0.586. Okay, so this answer comes to me, the arc length, which I'm talking about, this one, r theta. So theta is shift cosine of 5 over 6. So r theta times with 4. Now, if I want to write here the decimal answer times with the 4, let's see what I'm gonna get. I'm gonna write here, instead of this, I'm gonna write 0.586 and times with 4. 2.34. So my answer is 2.34 R, because I wanted to get the answer. He didn't mention I need to get the answer in exact form. So that's why it will not be very important to know that what is my sine theta. Maybe this is an extra work. So I want to find the shaded area. Ah, interesting. This shaded area is, I need to find this area, boys. And then I will times with 4. Do you understand? And this area has been sector minus triangle. So sector minus shaded area is, sector is half r squared, theta is 0.586, half r squared theta, theta minus triangle, half time base times height, which is r cosine of theta, 0.586, and then radius r sine theta, r sine 0.586. And then I can write my answer in a simplest form. Take the radius squared common. So inside you have half times 0.586 minus half cosine of 0.586 and sine of 0.586. Write everything in a calculator and then get your answer. I'm writing everything in a calculator and then multiply with r squared. So r squared is taken common. Ready to write everything in a calculator. Half times 0.586, then minus half times cosine 0.586, then times sine of 0.586, and then close the bracket. Then you get your answer. Is there any issue, guys? Is there any syntax error? Did I miss anything? Why the syntax error is coming? Did I put the bracket close? Check again. I have half times 0.586 done minus half times cosine 0.586. I need to close the bracket, then times sine 0.586, close the bracket. Oh, I put one bracket from my side, which was not needed. So 0.0626. So answer should be 0.0626 r squared. That should be the answer for this. But this is not my final answer. This is only for one sector. I need to times with 4. So I need to multiply this answer with 4. It gives me 0.25. So my final answer is, the final shaded answer is 0.25 r squared. That is the area of the shaded region. Are we done? Oh, wow. Circular measure is done. Thank you, guys. Keep watching the videos. And inshallah, this is the video number 1 and the video number 2 is on the way. Assalamu alaikum wa rahmatullahi wa barakatuh.